Hi there, the purpose of this video is to determine capacitor value by experiment. What we've got at the moment is we've got a little capacitor here. We can measure it on the meter as being 2.32. Can we verify if that value is accurate? Seems valid. Well, what we can do is use DC RC voltage across the capacitor charge curve. It's an exponential curve defined by Eulers number. One time constant gets you to 63% of the final voltage. We've set the final voltage to be 10 volts. The capacitor is going to charge up to 10 volts. If we measure the time to get to 6.3 volts, we know the time constant. We know the R value, which in this case is set to 1K, so we can calculate what the capacitor value is. Remove these out the way. Let us disconnect that capacitor from there. Let us connect the capacitor into the circuit. We will connect the capacitor into the circuit like so. Let us discharge the capacitor just to make sure that it's fully discharged. Put that on auto. It's fully discharged, 0 volts there. We put it on single and then we close the switch and we're charging it up to 10 volts. What we can see there, the time from 0 volts to get to 6.3 volts, that's the vertical difference, where that cross is the voltage there, 6.3 volts, that time is 2.38 milliseconds. If we take our 2.38 milliseconds, divide it by the 1K resistor, that gives 2.38 microfarads. That does verify the meter value of 2.32 within reason. What if we have a different capacitor value? We have 4,700, 4,700. We cannot measure that on the meter because it only goes up to 2,000 microfarads. But what we can do is put this capacitor into the RC DC circuit. What we will do is we'll put that onto auto. We'll discharge the capacitor down to 0 volts. We need to change the time base. Other way. Need to change the time base. Just double check it is 0. Put it on single shot. Acquire the charge curve. Okay, so we need to go across here. Let's just do it again. Discharge the capacitor. Make sure it is discharged. Because of the slow time base, it does take a while, and we'll press that again and see if we get the charge curve. We won't do that because that's the wrong value. Let's stick in 68, that's the right value. To get the charge curve, we'll discharge it. Let's put it back onto auto. Make sure we're discharged. What we'll then do is we'll put it onto single, we'll press, let's see if we can get the charge curve up. Now we've got the right resistor in there. Put that back to 100 milliseconds, we discharge it, yeah, we discharge it there, and what we'll do, put it back onto single, charge it up. We get the RC charge curve. Let's see if we can measure it to 6.3 volts. Let's see, we've got 0 volts there. We just need to move that cursor, not that one, not that one, not that one, not that one. We need to move that cursor there to where it crosses 6.3 volts, and what we're reading off there is 382 milliseconds. If we do the calculation, 382 milliseconds, We do that calculation, 382 milliseconds divided by 68, which is the resistor value. We get a value of 5,617 microfarads. Do that calculation there. Now that calculation, 5,617 microfarads, the capacitor is nominally 4,700 microfarads. It's a little bit out, but it may well be within the tolerance of the capacitor, and it still gives a good indication that that capacitor is working correctly, and we can measure its value. Thank you for watching.